Hello again, Tom from Every Step Calculus, everystepphysics.com. This problem is a little different from the other problem. Number one, the star is in front of this one, so that's what this video is about. You can do your homework with it. Probably won't be on a test. It's too hard for a test. Notice the answer is harder than the initial function, which is usual in calculus. Notice trying to remember all these things as I go through the steps, but I wouldn't memorize. I just buy my programs and you'd have it in your calculator for whatever test or whatever homework you're doing. And I've researched this many hours to get the proper way of doing these steps, etc. You know, checking with Wolfram Math, all these other sites, and a lot of them don't give you the correct steps that we need as students to complete the problem and memorize it and be able to do the test on a problem. So anyways, index 8 to get to my menu, main menu. We scroll down to u-substitution. You use this, of course, you know how to do that probably on your, from other videos that you've seen on mine. And we enter the function here. You have to press alpha first before you enter any functions into here in my programs, okay? And you'd enter the 1 and then the divide sign and then the x times sign, you know, etc. I've already done that in the simulator here to save time. So you can see this is the same as number 2. And when you do it on your titanium, after you buy my programs, you can, you know, if this isn't right, you can change it. I always give you an option of that. When it's busy here, it's loading the program for the first time. And of course, I try to explain everything. Notice a squared is 9 here. This is u squared, this is a squared, okay? And a is the square root of 9, so a is 3 throughout these steps here. So here's the original function. We're going to let x equal a times sine of u. These are all right triangles, pathetic right triangles with the Pythagorean theorem identities. And so all this, you know, for instance, the sine of theta is always the opposite, you know, over the adjacent. And here we go here. So then they come up with this identity here. Differentiate both sides. Turns out to be a cosine of u du, and then we just square it here to make it easy for future substitutions. So it's setting up the whole procedure. Then we're going to turn this into a substitution. So 9 is a squared, and then x squared, we just showed you that a squared times sine squared of u. We factor out the use algebra, of course, factor out square root of a squared, which is a, and then times the integral of 1 minus sine squared of u. Well, we have a Pythagorean identity now, and that equals cosine squared of u plus sine squared of u equals 1. Okay, a lot of times the u is, and most of the time, is a theta, an angle theta here for u. And then using algebra again, we transfer the sine squared to the other side, and we come up with cosine squared of u equals 1 minus sine squared of u. So the square root of this here, of this, what the original function, is a times cosine of u. Okay, so big deal to get that right. Okay, now we transfer it into the actual original function. Notice the dx is on the numerator, which it always is, even though you have 1 there. A lot of times they'll give you a problem like that. You have to know that the 1 is either there or else dx. Substitute dx, a times cosine of u, which we found, du, and the denominator is a times sine of u times a times cosine of u. Okay, because remember, x was a times sine of u, and then the square root of 9 minus x squared is a times cosine of u. Okay, so now these cancel. Notice a cosine of u canceled with the numerator. du is remaining, so I show you that. This is what's remaining. and then we're going to have 1 over a times the integral of 1 divided by sine of u du. Okay? Because this is really a constant, so I'm just showing you that you can divide the top here, 1 with the denominator a and 1 with the denominator sine of u. Okay? Now we bring out constants out of the integral sign all the time, so I've done that here. 1 over a is outside the integral sign here, and the identity of the previous screen is cosine of u du, cosecant u of du. Okay, so we have another integration rule. 1 over a is equal to times minus log of cosecant u plus cotangent of u plus c. Okay, that's when we integrate this up here, this is what it equals, and that's an identity integration. It's a rule that you're supposed to memorize on page 848 or something of your calculus book. And then we have another cotangent identity. Cotangent of u equals cotangent of u divided by sine of u, and reciprocal identity is cosecant of u equals 1 over sine of u. Okay, you can go slow when you review these things. Okay, now we're going to integrate, and we find what the integration is here. We're still doing algebra work here. Equals 1 over a times the minus log of 1 plus cosine of u divided by sine of u plus c. Convert back to x's and a's. X equals a sine of u equals x over a, right? We could figure that out if we knew what we were doing. And this, of course, we found was a cosine of a. So cosine of u is equal to the square root of 9 minus x squared over a. Okay, so we keep writing this on your paper, these different characters here. Keep writing it down. This is the way it's broken down into everything just like this. Now we have log properties getting into it too. You know, log properties, anytime you have a fraction, you know, x over log of x over a, it would be log of x minus log of a. You know, that's a trick in algebra that they taught you. And the answer here is minus 3 plus the square root of 9 minus x squared plus log of x all over 3 plus c, and that's what the answer is here. Pretty neat, huh? Go to my site, buy my programs. Why memorize and study this crap? Go to my programs for 40 bucks, buy them, put them in your titanium. You'll have them for the rest of your life, including for your grandkids or your partners in the future, and yourself in the future. You'll always be able to, like me, you'll always be able to answer these calculus problems if you have this titanium and don't ever sell it, okay? And of course, physics, the same thing there too. So, hey, good luck in your classes. Have a good one.